we don't have much time. Let's get to it, if you guys can hear me. Wonderful. So the talk today is about behavior change and role of machine learning in behavior change. I wanted to start with a rather morbid note, actually. Why should we study health behavior change? According to CDC, every year about 900,000 people, 900,000 Americans actually die prematurely, and this is even before COVID-19, from 5 leading causes of death. And a large portion of those deaths are preventable, again, according to CDC. Like 34% of the disease, deaths from diseases of the heart, 21% of cancer deaths are preventable, 33% deaths from stroke are preventable. And these may be also underestimation of how much of those deaths are preventable, because we are only now trying to understand epigenetics, right? As our understanding increases, we are now knowing that it's not necessarily nature or nurture. It is a mix of things. It's not what genes you have, but it is what those genes do. And there is this continuous interaction between the environment and your genetics. So even more deaths could be premature deaths could be preventable. So what are some modifiable risk factors? Lack of physical activity, poor diet, sleep deficiency, tobacco and alcohol usage, and maintaining healthy weight. So it sounds easy. It seems like it's trivial. We should do these things. Why is it so hard? In fact, health behavior change is hard and largely an unsolved problem. And so even when a person receives a life-threatening diagnosis, like a recent diagnosis of heart disease or a recent brand new... Oh, you know what? The button started showing up. Maybe I'll be able to share. Yay. Can you guys see it now? Oops. Can you see it? Oh, okay, good. All right, I'll go back to it. So yeah, we just covered that this is something important and we could actually save lives. Health behavior change is hard. And even when people receive life-threatening diseases, diagnosis, it is hard for them to make changes to their lives, because it's not just one decision of being, I want to be healthy, right? It is just hundreds of little decisions that we make is leading to living a healthy life. So such a complex problem actually requires a cross-functional approach. You need data science for sure, right? You need the power of data. You need machine learning, big data technology, statistics, experimental design, but you also need behavior science. It's not just predicting what the user is going to do. It's also how best to influence those decisions. So when we presented that there are deaths, 900,000 people die prematurely, and the solution is easy, you just eat better and then move. There is something going on, right? We're not rational beings. We have this hyperbolic discounting, for instance. We have all kinds of cognitive biases, and hyperbolic discounting suggests that if a reward that is far in the future is valued very little by us. If there's something in front of us, like binging on your favorite show on Netflix, versus aging gracefully if you were to not have any sleep deficiencies, we value Netflix show each time. So there is some cognitive biases that we have to correct for. So knowledge of behavior science, knowledge of health science, understanding the latest research in sleep, cardiovascular, mental, and metabolic health, all those things are important, and a cross-functional approach is absolutely necessary. And wearables companies are not the only ones who are recognizing that there is this last mile problem. There are many other industries that are realizing it's not just predicting user behavior, it's also changing behavior. And that requires the marriage of behavior science and data science. So at Fitbit, when we want to change people's behavior, we have a lot of tools that are available at our disposal, right? We have goal setting, which is shown to be very important. We have nudges, the correct nudge at the right moment, in the right context, that suggests you to do something, remind you to do something, can be very powerful. We have reminders, we have insights, making these connections for you, more structured programs, games, rewards, assessments, social, and health coaches, so human in the loop type of solutions. And it's our belief that data science has the power to make each and every tool that is available smarter and more personalized. So let's review some of those tools. You can have a context-aware insights. Well, why it works is the whole hypothesis behind wearables, right? If you have ability to see, if you self-monitor some sort of a behavior and receive data-driven feedback on that behavior in a compelling manner, which matters a ton, that would lead to a behavior change. So, for instance, if you were to notice that you're awake more than usual, so it is an anomaly for you, this is something that we think you should pay attention to, we can recommend solutions for you. If we are recognizing some blind spots that you may have, for instance, if your breakfasts are low in protein, and then not understanding how big of an impact it will have on the rest of your day, for instance, that could lead to some behavior change. If sometimes people just focus on the wrong metric, maybe we would just indicate that, yes, you are moving a lot, your mobility is great for your age gender group, but your intensity of your exercises are not high enough for you to benefit from, get the cardiovascular benefits you're hoping to get from your exercises. So let's just increase your pace. Or sleep. We could also ask you to look into some changes in your sleep environment, for instance, because of something that's different. Maybe your sleep duration didn't change significantly, but your deep sleep has declined. So that there is a chance that something about your sleep environment changed. Just from your wrist, we're just making suggestions, helping you solve problems so that you can get a better night of sleep. So what role does machine learning play in this tool? The discovery of relationships between behaviors and outcomes is a big one. We constantly look at our users and then identify the individuals who are healthy and try to see what are some of the behaviors that are associated with that health, right? And then we also use machine learning in order to understand what is worthy of mentioning, what is a significant deviation from the normal, what is unusual for you that requires your attention. And we also use machine learning in the presentation of those things. Like a single night of sleep can actually trigger so many different insights. Which one is the most important one that we should be telling you about? Would we have other opportunities to talk about this particular insight? So if it is the case, we would talk about thing that is more rare. So we won't get an opportunity to talk about all those decisions go into our recommendation algorithm. Nudges are powerful. They're simple but effective tools in a lot of different contexts. And machine learning can be used in understanding the context and understanding which teams you respond to and inferring the optimal frequency and time for each user. So when we talk about teams, there are all kinds of different teams. A powerful team is anchoring, just associating the behavior with something else that is already on your schedule so that you'll be able to do it at the same time. So meal times, for instance, are great anchoring opportunities. There's social proofing. All the cool kids are doing it. Maybe you should as well. just suggesting that they've already achieved the 65% of Fitbit users in your cohort, already reached the recommended active minutes today, let's get you caught up kind of messaging. Or some people need to understand that whatever they're doing is associated with a particular health outcome, and then how long it will take for them to reach that particular health outcome. So reminding of them that benefit is powerful. Or triggering some sort of a loss aversion, something that you already earned, and then if you don't do it, you'll lose your status type of thing. So, or challenging some of the big ones, challenging personal beliefs. A lot of people suggest that they don't have enough time to exercise. And then we have algorithms that suggest those moments where it is possible for them to exercise and taking advantage of that knowledge. So these kinds of experiences would allow us to create personalized and context-aware experiences. So understanding which themes you respond to and what the frequency with which you want to hear from Fitbit, for instance, would lead to different types of nudge experiences. We have more structured programs. So think of it as a course that you take. It's structured, supervised, goal-driven, habit-based programs. A static program will just not pay attention to the person's performance, but machine learning can create smart, dynamic routing of the program and variable duration in each step of the program before we allow you to graduate to the next phase based on the progress, and then delivery of making sure that you're motivated, making sure that we increase your ability. What are some of the things that would motivate you so that we're presenting you the right content to keep you motivated? So those are some of the things that machine learning can accomplish. We also have games, and gamifications has been shown to be an effective tool in a lot of different industries. Health and wellness is only one of them, but it is also education, marketing, and financial planning. And when we talk about gamification, we have a very loose term. It doesn't have to be a game, but it needs, would it be possible for us to make it fun? And then this is one of the games that Fitbit Research actually introduced, Fitbit Pet. And our own experiments also show that there is power of changing behavior is possible with gamification. And machine learning absolutely can make these experiences better by matching the player's ability, how hard it is, so that we could just set the bar a little higher than what they would have done anyways. Some generative algorithms so that we can introduce novelty to keep users' interest for higher engagement, and stochastic rewarding algorithms to mimic variable ratio schedule of reinforcement, which is shown to be more effective than fixed ratio reinforcements. So you can create personalized and more adaptive games with machine learning. And not all motivation is going to come from Fitbit, right? In studies after studies, it's been shown that social accountability is the second most effective factor in adherence to a program after supervision. So just matchmaking so that we're pairing you up with people to keep you accountable, for instance, is a role machine learning can play. And then when we create these groups, there could be some social engineering so that we can decide on the optimal size and makeup of a private group. At the Fitbit, we have these opportunities. We have feeds in people share their successes or failures or challenges and whatever experiments they're running on themselves. They share in these platforms, and then making sure that the content is very relevant to the individuals, and the people they're interacting with are people they can benefit from the most. Those are some of the things that machine learning can do. Finally, with behavior change, what we found is that there is no one size fits all. So there is no mix of these tools that will work on everyone. User one may need just very gentle interventions, like goal setting, nudges, reward, and afterwards they're do-it-yourselfers. But user two may be in need of more structured interventions, and then they need a lot more support and social accountability, or maybe even human in the loop type of solution. So machine learning can determine, based on things that are knowable even at the time that they join the Fitbit community, what is the appropriate set of tools for them to achieve their goals. So what is it that I would like you to take away from this very short presentation? If you're a data scientist looking for a job, and you have multiple offers, I would like you to consider favoring companies that will give you access to diverse data sets and diverse use cases. So a place like Fitbit, for instance, we have sensor-generated data, which is what people think of whenever they think of Fitbit. And so that tells us quite a bit about a person's activity, sleep, heart rate, and all kinds of other health metrics, SpO2, etc., skin temperature, etc. And then in addition to that, we have this application where people tell quite a bit about themselves. They log their food intake, they interact with each other in the communities in the feed, and then just share their stories. So there is opportunities for natural language processing, the opportunities for graph theory, because they create a network, they have friends, etc. They play games, so there is an opportunity to understand how people react to do those things. So just pick a place where there is a wealth of use cases that will give you the opportunity to learn most, especially if you're at the beginning of your journey and you don't necessarily know what you find interesting. If you're currently practicing data science, don't ignore the last mile problem. It's not enough to know predicting behavior, what behavior the user is going to display. Changing behavior requires a lot more than that. So learn about these different literatures, and then find opportunities to work with individuals who have a background in these areas: behavior science, behavioral economics, human-computer interactions, and game design. And if you manage a data science team, then I would recommend find opportunities to upskill your team with skills to deal with this last mile problem, and collaborate with other teams in your organization, or hire individuals who have a background in social sciences or behavior science, so that this cross-functional team that is capable of delivering behavior change will be available to you. I'm going to stop sharing. If there are any questions, I'll be happy to move to the breakout room so that you can ask. Thank you so much for your attention. Enjoy the rest of the conference.